Hello, my name is Charlie Scola, and today we are going to go through ICP 1, or the In-Class Programming 1, for Computer Science Knowledge Discovery and Management. So if you're watching this and you're not supposed to watch it, then why are you watching it? Okay, so what we have here is the code that first we got to import the libraries, done. And now we got to mount the drive, which I already mounted it. And then we got to make sure it's mounted again. And finally, we'll have to read the data. The data in this is just a simple text line. Text analytics have a lot of applications in today's online world. Blah-ba-dee, blah-ba-dee, blue. Okay, and now that we have the data now we have it as a Panda data frame. We have to convert it to text with this line. So now it has empty data frame slash in columns colon text analytics have a lot of applications. Gabbly gabbly goop slash in index. Okay, so now that that's done, we have to break into sentences by using the tokenize right there. And then now we're breaking the text into words. So this code right here, now all of it's in words. And the frequency of it, so there's 56 different words, 75 words altogether. The most common words being a period, or is that a comma? Period, and the word on. There's the distribution graph right here, just to make sure that it works. And now is when it is the portion I worked on. So first we're going to break the text into letters, because I figure that in analyzing data, analyzing each letter is just as good. So what I did was I made another list called character text, and all I did was just convert the entire string from the text file into the character. And then it got this empty data column, and that's the entire thing, but in character format instead of string format. After we did that, we used the frequency distribution to find out how many characters are on it. So there's 43 characters, and 43 different characters with 403 characters at all. So with all of that, we have 59 uses of the spacebar and 35 uses of the letter E. And the rest is all right here in this nice distribution. So of course the vowel is best. E is the vowel and it has the most. So that got me thinking, maybe we should calculate how many vowels are in this thing. That'd be good for data analysis. So I made this function right here. So while it goes through each of the letters in the text, and then if it is a vowel, notice how I have both capital over here and lowercase on this side, it will store it into this list. So we have it right here. Notice that the data is backwards though, because of the way that this code works. But for the purposes of this, it works just fine, because all we want to do is find the frequency distribution. So 8 different vowels are found with 128 outcomes, with the common one being E and O. And you can see the table right there. That looked weird the first time, but there we go. So at this point, I realized maybe we should have removed the noise in the beginning, but it was a bit too late to do that. So we're gonna take the noise out now, so that way in the future, if we have to do anything with this data, we'll have to edit it. To do that, I looked at the data itself, and the biggest noise that I determined is this part right here, that and right here. So in order to remove it, I noticed that everything inside this bracket is the actual text. So we just got to only read the data that's in the brackets. Now note that this will not work for every single type of text, only for this one, specifically because there are no brackets inside the text itself, and plus this might ruin it too. But this code right here, nope, not that code. This code right here, first I created a boolean for noise. If it goes into a for loop, first it determines if we're at the end bracket. If the end bracket's there, then there is noise. After that, it will see if there is no noise. If there is any noise, we append it, so that brings the string into the end of this list and adds it together. And then finally, what we do is we look for the bracket. If we find a bracket, the noise will remain false, and will only turn true once we see the end bracket. And as you can see right here, it has successfully took away the noise. Again, it will only work for this one though. Any other text file might not work. But that is it.